Hey, good evening, folks, and welcome back to my page, Astronomy by the Bay. We're here this evening to bring you a different kind of a broadcast. It's raining here in St. John, New Brunswick, and unfortunately, we're not going to get a very good evening out of it. So I guess last night might have been a better option for us, simply because we could have at least offered something through our night sky last night with a nice clear sky here in St. John. So just going to keep an eye out on comments here as we go through this. Hey, Paul, good evening. What I'm hoping to offer tonight, in the fact that two of our local astronomers that would normally give our night sky views are both busy this evening. And it's raining throughout the rest of the province and throughout Nova Scotia at the moment. So we're not going to have an opportunity to offer live views here tonight, but to help out some people who have sent me a number of questions about the night sky, and I get them all the time on my Facebook page and through Instagram and other locations. I thought what I'd try to do is offer a bit of a presentation on how to find your way around the night sky. Excuse me. So that's the idea here tonight, is to offer you a bit of a talk. This presentation was something that I had offered over a 6-week course that we had offered called A Beginner's Guide to Astronomy. And through the weeks that we had going there, thank you, Emil, for sharing that. Through the weeks that we had going there, we offered a talk on telescopes, a talk on the night sky in general, how to get started in astrophotography, and many other topics that brought us to the point where we were hoping that the beginners that left the course actually were able to take home some information that applied to them. So I know it's a very difficult thing to take a look around the night sky and find your way around. And what we're going to do is offer a series of these different presentations along the way throughout the next few months or so. We'll have a talk on telescopes, we'll have a talk on astrophotography and other topics, just to get you a little bit more familiar and to help us cover off some of these cold, dreary nights that we're getting now, and of course the rainy nights that we get that we really don't want too many of, but we'll carry on. Anyway, I'd like to keep the show live as often as possible, so I have one screen here up with the presentation showing. I have another laptop set up with the YouTube live stream showing right now, so I can watch comments as they're coming in. And if you have any comments or questions, please go ahead and let me know, and I'll be watching for them as we go through this presentation. So I'm going to start the slideshow here now. And basically what it is A Beginner's Guide to Astronomy. And a little bit about ourselves, though, first of all. I'm a member of the St. John Astronomy Club, and the other members that are on here with me at times will also be members of either their local clubs or a member of the Royal Astronomical Society of Canada. Now, the RASC, we call it, of Canada, is an organization of about 5,500 members, and they're located across the country. Some of them are professional astrophysicists, professional astronomers, people like myself, just amateurs, and those of us who just enjoy the night sky together. So I do recommend that you take a look at the RASC. Their website is just rasc.ca. They have membership information available there, and they have lots of information to offer you as well. So I'm going to come right up front here and just tell you that I am just an amateur astronomer who loves setting up my telescope for people who like to take a look at the night sky. So some of my slides here may not be exact as far as factual goes, but I've tried to lay them out as pleasing as possible. So let's get started a little bit. So what do we do normally? Well, we have regular monthly meetings here locally to discuss the night sky and to share our common interest through talks and observing. And we do lots and lots of outreach, as you can see. We set up quite regularly at a local beach here, Saints Rest Beach. We're involved in many other activities. We volunteer with the presentations and night sky observing through our telescopes while visiting schools, youth, and special interest groups of all types. We also have a series of star parties that are offered at designated dark sky parks here in New Brunswick and other provincial and local parks as well. So a star party event is usually a weekly event. Weekend event, and it takes place. We have 5 of them actually throughout New Brunswick throughout the year, and they take place in the provincial and national parks. So we gather together as a group of amateur astronomers and set up in some part of the park, and then we invite the public in for 2 evenings in a row to enjoy the night sky with us. And all you do is pay for your admission to the park, and everything else that we offer here in New Brunswick is free. And we support the Irving Nature Park and the Rockwood Park here in St. John through the regular outreach events open to the public. The Irving Nature Park is the first urban dark sky park in Canada. We offer mentoring to anyone who asks for it, and we often set up for the public at local spots like St. Rest Beach, where my favorite spot is, I guess. So, a little bit about the night sky. What do we know about the night sky? Well, we're all familiar with this image, I guess. We'll go back to one here. And we can zoom in on our Milky Way, which is 100,000 light years across. 1 light year is 10 trillion kilometers. Here we're zooming into our location, the Milky Way. We're about 26,000 light years from the center of the Milky Way. And as we turn away from the Milky Way now in the wintertime sky, we're looking back into blackness of space. Here are a lot of the common stars that we see in our sky: Aldebaran, Betelgeuse, Procyon, Sirius, and of course our sun, Sol. Well, most of the videos that I picked up here are off of the NASA website, NASA and ESA websites. And as we zoom in, of course, here we get a better look at our whole solar system. And a little bit about our solar system in general. Everybody's seen this model, I guess, back when we were kids. 8 planets now, with Pluto mentioned as a dwarf planet. I'm going to get a little bit into the explanation of that too as we move along. Now, remember, this presentation I'm offering is more for beginners than those who are intermediate or advanced, but it's to hopefully provide a little bit of a view of what we see in the night sky and why we see what we do when we do. So we're all rotating. If we were looking from above, we would all be rotating counterclockwise around the solar system. And I'm going to spin out now to a diagram that comes from the Heavens Above website. This is the website that I do recommend people go visit if you want to get more information about planets, the sun, the moon, and such things as comets, the International Space Station, where it is. All you have to do is go to the website, plug in your location, in my case St. John, of course, and from there I can click on several different buttons that'll give me more information about where the planets are, what's happening with the planets, that type of thing. But this is something that they have on their page called the Solar System Chart. So this is a current view of our solar system from looking from above, looking down. So we're in a spacecraft, we're looking at the whole solar system up from above the solar system, looking down on it. And in here we can see that the closest planet in there is, of course, Mercury, then Venus, and then Earth is blue, and then Mars. And then that's all sitting inside that smaller square inside there. And then we have Jupiter, Saturn, Uranus, Neptune, and Pluto all drawn up there as well. But I went ahead and drew it up this way. This is, I'm not much of a drawer, but this is basically how I see it. We're all elongated orbits, basically, going around the sun. And I drew this a little bit up in paint just to have a quick look at how things are moving around. So if you picture this now, again, looking from above the solar system, and we're looking down on top of it, and everything that we see here is going counterclockwise. So that's why I've got the large yellow arrows here in the sides. And why I did this was to basically explain to you why we see the planets where we do at the particular time that we do. So let's take a look at Earth there, just to the right of the sun, top right of the sun, and we can see that the Earth is rotating counterclockwise as well. So let's picture ourselves at the top, say, left corner of that picture of Earth there. And if we were rotating counterclockwise, before the sun would come up, we would see that we would see Mercury first, and then Mars, and then the sunrise. So let's go ahead to the next drawing, and here we are on November the 25th. And now for the next number of mornings, we're going to take the moon out of that shot because the moon is there, of course. It's just a small sliver of a waning crescent moon right now. But if we look there, we'll see that we have Mercury and Mars at 6:45 before the sun rises. So that's why we see the planets where we do, when we do. That's one particular example. Let's go back to our main chart again here. And we're going to go back to looking at the Earth again. We're still standing on the top left corner of the Earth, moving around. Okay, we've come by Mercury, Mars, the Sun. Our day has moved along, and now we're into sunset. So now at sunset, we should see Venus and Jupiter and Saturn in our sky. Look below the drawing of the Earth there. As we rotate counterclockwise, the Sun would disappear, and then the next three objects up would be Venus, Jupiter, and Saturn. And here we are in our evening sky, and we're going to get into this a little bit later too. A little bit of talk on where the planets are this coming week, because there's a particularly nice dance of the planets going on right now, and it's going to happen over the next week or so, and we'll have lots of opportunities to get outside and capture a nice photo or two. So here we have Jupiter and Venus, and this is this evening, I guess, the 24th, where Jupiter and Venus are sitting only 1.5 degrees apart in the sky. So that's about the same as the distance of 3 full moon widths apart. And we're going to watch this later on in a program called Stellarium, which is where this is all coming from, Stellarium. And it's a free program that's downloadable to your tablet or to your phone or whatever. And it works very well in bringing up information about the night sky. So here again, we see Jupiter and Venus in our drawing, and we see Saturn up on the opposite side there. So what's happening right now is Jupiter is setting as we rotate around faster around the Sun, and we see Venus is starting to rise. So let's move ahead back to our picture one more time here. And now we see that we have Venus and Jupiter and Saturn up, and now we're going to spin out to Neptune and Uranus as well. So as we rotate and the Sun has set, Venus, Jupiter, and Saturn are in our evening sky, and of course they will set too as we rotate farther around. And then we're going to see where Uranus is. There's Uranus in our evening sky. This is set up for about 7 p.m. I guess. So Uranus is just under Pisces there. And then back to our chart again, and we see that Neptune is sitting here. So it should be in our evening sky if we're sitting on that same spot on the Earth. Rotate it around again, and there's Neptune sitting there just under Aquarius. So that's a quick view of how we find our way around the night sky and why the planets are where they are. So I'm just going to go back to comments here again. Eddie, how are you? Dave and Mike and Peter, good evening. Now, a little bit about this guy, our Sun. Of course, our Sun is a star. And if the Sun were about as tall as a typical front door, the Earth would be about the size of a nickel. The Sun makes up about 99.8% of the mass of the entire solar system. At the equator, the Sun spins about once every 25 days, but at its poles, the Sun rotates once on its axis every 35 Earth days. So picture a big ball of plasma or gas that rotates at many different speeds. The Sun is a ball of gas about 92% hydrogen and about 7% helium, all held together by its own gravity. And the only thing that keeps the Sun from blowing itself apart is the fact of its massive gravity holding it back together again. Those are sunspots that are traveling around there, and sunspots are caused by the huge magnetic field that is being caused by the Sun's rotation. It rotates at many different speeds, so its lines of magnetic force get twisted all up. This is the planet Mercury passing in front of the Sun. I'm sorry, the planet Venus passing in front of the Sun from a few years ago. And now we're seeing the Sun in different types of wavelengths of light. which allows us to see many of the sunspots and solar flares. The Sun would hold 1.3 million Earths, and of course is 160 million kilometers away from Earth. And 99.8% of all the mass of the whole solar system resides in the Sun. And I'll take this ahead one more time. Here's the view of the Sun in what's called H alpha. So we see the Sun in visible light, but there are many other types of light that the Sun can be observed in, and one of them is called H alpha. And there are special telescopes that are designed. I have one that is designed to look at just the Sun and nothing else. So we use what's called an H alpha or hydrogen alpha filter. So the Sun is again, all different wavelengths of light, and we sliver out this one little piece of wavelength of light called H alpha, and we can observe the Sun in this format. So in this format here, we see that there's these large loops of plasma that are actually faced back at us now. We call these prominences, and you can see them up around the edge of the Sun as well. And here's a typical sunspot in comparison to the size of the Earth. So we have an idea here of how the Earth would appear next to a sunspot. And I'm trying to go back to comments here. I'm doing this all on the fly here, on my own. So bear with me. I've got two laptops going. I've got tablets here sitting beside me and a few other things just to gather my notes together. And here's typical sunspots as we see them through the telescope. So we use a special filter that sits over the front of the telescope. And it's a white light filter, so it filters out about 99.9% of all the visible light that's coming through the telescope, and all that's left is something that's safe for us to view. So this is how we would view sunspots as they come through the telescope. Next little slide I wanted to show you is just a bit about the planets and their orbits, their tilts, I'm sorry. So we know that that Earth is tilted at 23.5 degrees, and that's what gives us our seasons. But the other planets are also, most of the other planets have a tilt as well. You can see Mercury here has no tilt at all really. And Venus is actually tilted right upside down, 177.4 degrees, almost 180 degrees upside down. And we're not sure why that is. Perhaps Venus was hit by something very early in our early days of the solar system and caused it to turn upside down. We look at Earth here at about 23.5 degrees tilt. Mars is roughly about the same tilt as us, so Mars, of course, also has seasons. Large Jupiter only tilts at about 3 degrees. Now, we're looking here also at the spin rates, and we can see that Mercury and Venus they don't spin hardly at all. Their rates are very slow compared to the rest of the planets, but we'll get into that talk too a little bit later as we get into talk a little bit about the planets themselves. And Saturn is tilted at 26.73 degrees. Uranus is almost tilted directly on its side at 97 degrees. Neptune is sitting at about 30 degrees, and Pluto is sitting at 119 degrees. Thank you, Maggie, the lone astronomer. That's true. And Mike is watching 9 screens tonight. Good for you, Mike. Much more than I could ever watch, for sure. Okay, so our next little slide is on the planet Mercury. And Mercury, of course, is the closest planet to the Sun, which makes it very difficult to view, as it never really travels very high above the horizon. For every 2 orbits around the Sun that Mercury makes, though, it makes 3 rotations on its own axis, so it doesn't rotate very quickly. And about 13 times a century, Mercury can actually be observed passing in front of the Sun. And we call that a transit, and that actually happened on November the 11th of this year. A very cloudy day for us here in St. John, for sure. A day on Mercury takes about 176 Earth days, and a year on Mercury is only 88 days. So a day on Mercury is actually longer than a year on Mercury. Sounds pretty unusual. Mercury is the smallest planet. It's slightly larger than our moon and about 1/3 of the diameter of Earth. Although Mercury is the smallest planet, it's very dense. It's mostly due to the fact that it's composed mainly of heavy metal and rock. Only Earth is more dense. a little bit more to talk about here. So even though Mercury is the closest planet to the Sun, Venus is actually hotter. The surface of the Venus can be up to 460 degrees, while the temperature on Mercury, on the side facing the Sun, reaches about 427 degrees. At the same time, the other side of Mercury reaches about minus 173 degrees, since there's basically no atmosphere on Mercury. And Mercury is the most cratered planet in the solar system, probably caused by numerous encounters with asteroids and comets as it gets in the way of the Sun. Mercury just has about a third of the gravity of Earth, which is really too small to hold on to any atmosphere. That gets blown away by the solar wind. So the wind does emit solar energy in the form of solar particles that get emitted from the Sun, and it strips the atmosphere away from Mercury because it's so close. But it does get replenished somewhat by the same solar winds and dust that carry out micrometeorites. Mercury only has a slight tilt, about 2 degrees, meaning that it doesn't experience seasons. And it has a very weak magnetic field. So that's some facts about Mercury that you might want to pass on. Of course, the next planet out is Venus. Venus is, of course, the second planet from the Sun, orbiting the Sun every 225 days. And it has the longest rotation period of any other planets. And it takes Venus about 243 days to rotate once on its own axis, which means that a day on Venus is longer than a year in Venus. It also rotates in the opposite direction of all the other planets, so on Venus the Sun would rise in the west and then set in the east. It's the third brightest object in the sky, next to the Sun and our Moon, so we can actually see those tonight if we're outside in the southwest, and you'll notice that Venus is very bright. So we have the Sun, the Moon, Venus, and then Jupiter. And that's because Venus reflects, its atmosphere is mostly carbon dioxide, and it reflects about 95% of its energy back into space again. It's light. It's bright enough actually to cast shadows at night too, and can be seen with the naked eye in daylight if you know exactly where to look for it. One of our local astronomers can find it pretty well every time in the daytime when it's up. It never really appears to venture too far from the Sun, and as an inferior planet, it does show us phases, just like our Moon. So Mercury and Venus and the Moon give us phases. Venus is sometimes called Earth's sister planet due to its smaller size, and it's named after the Roman god of beauty, but that's about where the beauty ends. Venus has the densest atmosphere in the solar system and is about 96% carbon dioxide. If you were to stand on Venus, the atmospheric pressure on you would be about 92 times the pressure you experience on Earth, about the same pressure as being about 3,000 feet below the ocean. It's also by far the hottest planet in the solar system with a surface temperature of about 460 degrees Celsius. It's surrounded by a very thick layer of highly reflective clouds, sulfuric acid, and it may have had water on its body at one time, but they would have been vaporized long ago due to the greenhouse effect. Sunlight gets trapped in its cloud layers, and it causes the planet to heat up. Since we can't see through the clouds of Venus, we have to use spacecraft with radar mapping ability to be able to see what's on the surface. And we did that, and we found out that Venus is covered really by smooth volcanic plains. Venus had mountains as well, with its highest rising about 11 kilometers above its surface. The surface has very few impact craters, indicating that its surface is most likely very young, perhaps only 300 to 600 million years old. Venus also has many volcanoes, over 160 of them, are more than 100 kilometers across. So some data on Venus. A view of our planet Earth from the Galileo spacecraft. Of course, the only place in the solar system so far that we've been able to find life. And we exist in the habitable zone around our star, which means that liquid water can exist on our surface. And that's one of the main keys, I guess, in allowing life to exist anywhere. Just flipping back and forth to the comments here, making sure I'm not missing too much. Again, if you have anything to add to it, please just go ahead on the comments. And I guess we'll spin out. We'll keep going here. We're getting 8:34 now, so things have moved on a little more quickly than I expected. How about our moon? This is a view of our moon taken from the LRO spacecraft. And in this view, we get to see the whole moon, including the side that doesn't face us. I could do a talk completely on the moon itself, and that's probably saved for a later date. There's a whole lot of information to talk about on the moon, about the moon. And like these large dark gears that we see here that we call Maria. And these are large dark volcanic plains that were formed roughly about 4 billion years ago. There's many new features here that are new to me now because the fact that we just put on a course called Explore the Moon. And I guess some of the ones who will be on the live feed here with me tonight took the course with us, and we learned a whole lot about the moon and its origin and that type of thing. But we're going to talk a little bit about its origin here now. So here's our early Earth, back about 4.5 billion years ago. And of course the solar system was full of debris left over from the formation of the planets, and as the planets orbited in their paths around the sun, they picked up more and more debris, which made them larger and larger into shapes of balls. And the gravity would haul in more articles, but then there was a large body that we think, this is the theory of the leading theory about the moon. It says this large body called Theia, about the size of Mars, came crashing into our Earth in its early days. And it, as you can see, it almost destroyed us. But material was ejected up into space. And of course the two bodies fused together to bring a lot of the same material together, and then this material that was cast out into space eventually coalesced to form our moon. But in dramatic footage, but of course didn't happen that quickly. And the reasons why we know that is because we've landed on the moon. There have been 6 missions, manned missions to the moon. All took place between 1969 and 1972. The first man on the moon, of course, was Neil Armstrong. The last man on the moon was Eugene Cernan in Apollo 17. And these are the locations on the moon where they did land. So we brought back over 850 pounds of moon rocks, and they analyzed the moon rocks. Much smarter men than myself, and came back with lots of data about the moon and its formation. And there were 3 theories actually about the moon. One was that it was a captured moon, and there wasn't enough similarity between. There was too much similarity between the Earth's crust and the moon to say that it was a captured moon. Second one was that the moon and the Earth formed at the same time. Well, roughly they did, but the materials again didn't balance out. So the third theory, this theory that we were hit by a body about the size of Mars, is the leading theory today. And here are the landing sites, courtesy of the LRO, which is the Lunar Reconnaissance Orbiter. So not only has it never been announced by any other country that the Americans never went to the moon, here we have evidence of the lunar landing sites. So in these photographs that were taken about 60 kilometers above the moon's surface. Just reading your comment there, Peter. The Earth looks round, as do all the rest of the planets. How do flat earthers come up to their opinions? I can't touch that topic tonight. Maybe for another show. So here we have 6 views of all 6 sites of where we landed on the moon. So what we see here is the discarded caps and covers and stuff of the scientific experiments. The top left picture shows the Apollo 11 lunar lander in the Sea of Tranquility, And if you look close there, you can see actual footprints leading out from the lander out to the crater, the famous crater that Neil Armstrong threw the bracelet in the movie. And lower photograph there, the one across from it there on the right is the Intrepid descent stage. So, of course, they had two pieces of a spacecraft that they landed with. One piece was the descent stage, and then they had the ascent stage, which is the piece that they used to launch from the moon. There you can see a lot more traffic, a lot more footprints, and you can see footprints leading all the way down to the Surveyor 3 spacecraft that had landed on the moon earlier. And they went to recover some material from that spacecraft and brought it back to Earth. So this showed that they could actually do a precision landing on the moon, which was really neat. Apollo 14, we're getting into the Antares descent stage and more scientific instruments. Then, of course, we took the LRV to the moon, which is the lunar rover vehicle. You can see it on the center photograph there on the right photograph. On the bottom right side, the LRV is sitting there parked. And then again on Apollo 16 and Apollo 17. So lots of information there. And you can go to, all you have to do is go to NASA LRO, or Lunar Reconnaissance Orbiter, and then type Apollo, and it'll bring you up all of the images that are shown here. And here's a view from the Chinese spacecraft that recently landed on the south pole of the moon, a view of the moon from the backside and how tiny Earth looks from the moon. And here is basically a chart showing all of the major areas on the moon, all of the seas, or they're called seas: the Sea of Cold, the Sea of Showers, the Ocean of Storms. The Ocean of Storms is called an ocean because it was larger than most of the other ones. But back in the days of Galileo, they looked at the moon and they thought these were seas. And they do look like dark patches where water would exist. Of course, there's the Sea of Tranquility on the right, the Sea of Crises. That one there, top right-hand corner, is about the same size as New Brunswick. And then we have several craters all along the edge there. So these are the major features of the moon. And probably down the road, when we get another rainy night or so, we'll take this drawing and we'll pick it apart, and we'll take a look at more about the formation of the moon, the origin of the moon, and some of the features that can be offered through the telescope. I know, Daniel, it's amazing what was done 50 years ago. It really is. And what could we do today? I guess it just takes money and the will of the people to go back again. I hope I'm able to see the next moon mission for sure. So a little bit about the next guy, and again, we're just going to continue here. Remember now, folks, that this is mostly laid out for beginners, so I'm trying to cover material that they may be interested in. And of course, we're talking about Mars now, the fourth planet from the Sun, the most explored planet, really, of the whole solar system. We've got a rover on that planet right now, a few of them that have passed on the planet. It's the second smallest planet in the solar system after Mercury. Mars became the Roman god of war, basically, and referred to as the red planet. It's because of the effect of iron oxide that's prevalent on Mars' surface, which gives it the reddish appearance that we see here. It's very distinctive among the astronomical bodies, visible to the naked eye, very visible to the naked eye, as we can see it in the morning sky right now. And Mars is a terrestrial planet with a very thin atmosphere, having surface features reminiscent of both impact craters of the moon and valleys and deserts and polar ice caps as well. Mars seems to be the place we're going to next after we get to the moon. I guess the real venture is going to be how do we get to Mars and how much money do we have to get there. So our exploration of the moon, in my opinion, probably does have to come first. We've learned a lot about living in space from the International Space Station. They're growing vegetables up there, all kinds of things. But we're still kind of within the protective environment of the planet in the fact that we have to deal with things like cosmic rays. We have to deal with solar radiation, solar storms that may occur when you're on a planet like this. Also, you've got to think about the fact that it's going to take 8.5 months to get there. So 8.5 month journey to Mars sounds like a picnic, but you're basically inside a tin can, and you best like the people that you're traveling with, for one thing. Secondly, when you get to Mars, it's not like you're going to be able to take off your helmet and walk around. There's a very thin carbon dioxide atmosphere there, certainly not breathable. And then when you're there on Mars, the idea is that we would launch from Earth when Mars is ahead of us, and then the spacecraft would catch up to Mars, and then we would, of course, since we're going around a lot quicker, you would be traveling around faster. So you'd have to stay on Mars until we caught back up to you again and actually passed you, and then you would launch from Mars and catch up to us. So you're looking at about a 2.5 year mission. So it's quite a commitment from astronauts and from the space agencies, the whole bit, to make a mission to Mars really happen. Can it happen? Yes, it can. It just takes the will of the people and the will of the country to be able to say that that's our next mission. But I think realistically, we got to get to the moon first, and we can't just go to the moon and stick a flag in the soil. We have to stay there for a while, and maybe it's a month or two at a time, just to get ourselves accustomed to the fact of what it is like to really live in the harshness of space. And so that's the next part of the mission. That's Mr. Trump's mission, I guess, is to take us back to the moon. And I think NASA's on board with the Artemis program, and I think that's what we're going to see next. And they do expect us to be on the moon by 2025, so that's not too far away. So I wish them the best of luck, and I hope it materializes, as I'd love to see it happen for sure. I'm just going back and forth here to comments again. And of course, after Mars, we're going to get into the asteroid belt. And just take a second to read that. A little bit about the asteroid belt, as I just kind of flim through my notes here. This animation, and again, I've captured this from NASA site. All of these are available on NASA site. The animation represents a map of the increased count of all known asteroids in the solar system between January the 1st, 1999 and January the 31st, 2018. So we've all seen or heard about near-Earth asteroids. We've had a number of them that have just missed us in the last year or so, I guess. And usually they're so small that we don't get a chance to find them until they've actually zoomed by us. And so here's a little bit of a representative of what we're dealing with when we talk about defending the planet against asteroids. So let me run this through for a little bit. So what's going to come up is a map of the known asteroids and the collection of them. Here's the known near-Earth asteroids as of January the 1st, 1999. And what happened shortly after that was we got better and better with our telescopes and our spacecraft. And here's what we're facing at the moment. Near-Earth asteroids as of 2018. And these are all the known asteroids as of 2018. So as we zoom in here, look for this the blue line, the grayish line there, and you'll see that that's the orbit of Earth. And you can see the number of near-Earth asteroids that actually cross our path. Let's go back over that again for a little bit. We'll zoom in here. And there. All these small tiny dots that are passing through the gray area are what we call near-Earth. There's Earth at the top of the drawing of that gray area there, the gray circle. And you can see the number of known asteroids that are actually passing through our path as we travel around the sun. Now, this bigger yellow belt that we see all the way out there, that's actually the asteroid belt, of course, between Mars and Jupiter. So it's a lot thicker in that area. But let's just move ahead here again for a little bit. And those are just the known ones that are mapped, and roughly about, I don't know, I'd say probably about half a kilometer across or larger. Those are the ones that they're picking up at the moment. So, of course, next we come out to the planet Jupiter. And Jupiter is the fifth planet from the Sun, and it's actually 2.5 times more massive than all the other planets combined. It's known as the gas giant, and one of the four that are out there. Jupiter is the fourth brightest object in the solar system. Only the Sun and the Moon and Venus are actually brighter. And Jupiter has the shortest day of all the planets, as it rotates on its axis about every 9 hours and 55 minutes. It orbits the Sun every 11.8 Earth years. So orbiting on its own axis every 9.5 hours, or every 10 hours, I guess. So if you were able to see it, you'd be able to see the red spot twice in a day, I guess, if you were able to catch the Jupiter up at 2 times like that. Let's go back again. It has a very unique cloud feature. Its upper atmosphere is divided into cloud belts and zones, and they're made primarily of ammonia crystals, sulfur, and a mixture of 2 compounds. Jupiter has a massive storm raging in its atmosphere for over 350 years, this great red spot, and it's actually an anticyclone that could swallow the entire Earth. We believe Jupiter's interior is made of rock, metal, and hydrogen compounds. Below Jupiter's atmosphere, there are layers of compressed hydrogen gas, liquid metallic hydrogen, and a core of rock, ice, and metals. Jupiter does have a very thin ring system, mostly comprised of dust particles ejected from some of Jupiter's smaller moons. So I got to move ahead here because we're getting into 10 to 9 and we're getting quite late in our show. So here's a view through the eyepiece of a telescope. Not the particular view tonight, but through most telescopes, and I'll say even the smaller ones, about 3 inches or around that size, will reveal Jupiter and at least 4 of its moons. These are the 4 Galilean moons, the 4 that Galileo discovered back in 1610 when he was looking at Jupiter with his little tiny telescope. So I'm going to spin through these slides a little bit quicker now because it looks like I'm going to be running out of time. I did say an hour long, and that's where I'm trying to keep it. So let's go ahead to take a look at the 4 Galilean moons that Galileo discovered. And I'm just flipping through a few pages of notes here, just to be sure that we're still covered. So we have Io on the far left. We have Europa, the smallest moon there, and then Ganymede and Callisto. Those are the 4 moons that we can see ourselves through the telescope. So anytime that you point your telescope towards Jupiter, you may not see the 4 of them in a row like this. They may actually be separated quite a bit. You may have 4 on one side and none on the other. It just depends on their orbits. But it's like a little mini solar system. Jupiter has a total of 79 moons altogether, but 4 of them are very visible through the telescope. The largest number of natural satellites of any of the planets, but actually that's changed now. It's actually Saturn has 82 moons, so it's moved ahead. And it looks like my live feed may be stuck at the moment. Not sure what's happening here. Chat disconnected. I'm going to try to connect to you. Connect to chat. Please try again later. Okay, chat's offline. Okay, chat's offline, and there it looks like we're coming back again. So we took a bump there for a moment, I guess. The largest objects in the solar system after the Sun and the 8 planets, and Ganymede is actually the largest moon in the solar system and is even bigger than the planet Mercury. In fact, if Ganymede was to orbit the Sun, it would be called a planet. Now, Io is the innermost of the Galilean moons and has a diameter of about 3,600 kilometers and is the 4th largest moon in the solar system. It has more than 100 mountains, which are taller than Mount Everest. Io is composed of silicate rock surrounded by a molten core of iron. Io may even have its own magnetic field. It does have an extremely thin atmosphere of sulfur dioxide, and if you were to land a craft on Io, it would actually have to be tank-like to withstand the intense radiation and magnetic field of nearby Jupiter. Io is the only other body in the solar system known to have active volcanoes. So we found those with the Voyager spacecraft when we went out by that in the late 70s and early 80s, I guess. Moons have elliptical orbits. Just as they get close to the massive planet, Jupiter's gravity tends to squeeze them and stretch them, and that's what causes the friction and heat. So Io is the really interesting one in this photo. The fact that Io is, and there's another image of it right here. Here's Io rotating. Io is the most volcanic moon in the whole solar system, simply the fact that it's so close to Jupiter that it gets stretched and skewed in its elliptical orbit as it passes around Jupiter. And Europa, which is this one, is probably one of the most interesting worlds out there, because we believe that Europa is covered with about 10 kilometers thick of ice. And underneath that, we believe there's a global-sized ocean, again caused by the same friction happening, where Io is stretched and skewed so much that water is abundant underneath its surface. And we can see these large cracks that are all around the surface here that are allowing water to come up and freeze, and come out and break through the surface and then freeze again. And in the next couple of years or so, we'll have a mission going out to Europa to analyze that a lot further. I'm going to move ahead in our slides. This is Ganymede. Ganymede, again, the largest moon in the whole solar system. And we're going to go to Callisto, the most heavily cratered moon in the solar system. Again, I'm going to spin out a little bit farther here so we can move into beautiful Saturn as we move our way through the planetary system. About 1.4 billion kilometers away. You could fit over 900 Earths inside of Saturn. The ring system is about 100,000 kilometers across. It has now known 82 moons, and one of the great moons of it, Enceladus, is actually spewing geysers up. And as part of the ring system deplenishes, it's known now that Enceladus' moon replenishes part of the ring system. Saturn looks very big. Of course, 900 Earths would fit inside it, but if you could actually find a bathtub large enough, you could float Saturn in water. That's how light it is. And it's always a beautiful view through the telescope. The two objects that probably fascinate people the most are this view of Saturn and the moon. Moving out to one of the moons of Titan, which is one of the largest moon of Saturn. Titan is surrounded by very thick haze. We're never really able to look below the surface of Titan, but radar mapping with special spacecraft can actually strip away the clouds, and we can see what's happening on the underneath. And underneath we find these huge lakes of liquid methane. And if I move ahead just to another shot, which I'll try to skim through very quickly, is the Titan touchdown. So back in 2005, Saturn had a spacecraft visited called Cassini. And Cassini spent some time around Saturn, many years, and it launched a small probe called Huygens that was sent down to explore Titan's atmosphere and its planet, or its surface. So it entered the atmosphere of Titan, which we can't really see below. And this is footage that was captured from Huygens that transmitted the information back up to Cassini and then back to Earth. And it shows, it actually came down through with a parachute. And it shows some of the data that was collected from the moon Titan. So here we see these large mountains approaching, and these large dark lowlands where a lake bed may have formed. Researchers thought it had large lakes, so Huygens was designed to float just in case, because they weren't sure exactly where it was going to land. Cassini later showed us that large lakes and seas are confined to the poles, And here it is falling down through the atmosphere of Titan. And here it is about to rest on the dark floodplain. And look at that. Pebbles. So we know there are other bodies out there that have liquid on their surface. And that was the key for this one. And Enceladus, one of the moons of Saturn, that is another fascinating world that is also surrounded with ice. And we believe a global-sized ocean underneath it. And Enceladus we've been actually seeing geysers spitting from Enceladus. And they're known to have water ice. So water is abundant, we're finding, in our solar system at least. And water is one of the main components that creates life. The planet Uranus. Uranus is, of course, tilted on its side at about 90-degree angle there. And Uranus is, of course, the seventh planet from the Sun and was officially discovered by Sir William Herschel back in 1781. Uranus and Neptune are both called ice giants, actually, since they have an upper layer made of hydrogen and helium. And below that, an icy mantle, which surrounds a rock and ice core. The upper atmosphere is made mostly of water and ammonia, and methane gives it its color. Uranus has the coldest temperature of any planet in the solar system, minus 224 degrees. It also has 2 sets of very thin rings, and it has 27 moons. Quickly on to Neptune, before I run out of time here. I'm already at 9 o'clock. I started about 10 minutes late here because I was having some trouble getting the broadcast software up and running. But here we're moving into Neptune. Neptune, of course, is the 8th planet out and was first observed in 1846. It spins on its axis very rapidly. Its atmosphere is mostly hydrogen and helium with just a touch of methane. And methane absorbs the red light, which gives the planet its blue color. Large storms here whirl throughout its atmosphere, and it has 14 moons. Only one spacecraft has ever visited Neptune, that's Voyager 2. A little bit about Pluto. Get lots of questions about why Pluto is no longer a planet. Well, there's nothing saying that it's not a planet, and it is a planet. It sits in the category now of what we call dwarf planets. And the reason why is because we found other worlds like Ceres and Eris and other worlds that were out there as well. We said, okay, well, where do we draw the line about what makes a planet and what doesn't make a planet? So the International Astronomical Union got together and decided to lay down some ground rules on what we would call a planet. So in this case, a planet, these were the rules that they made up. A planet must orbit the Sun. Does Pluto orbit the Sun? Yes, it's kind of an elongated orbit, but it does actually orbit the Sun. So Pluto made it by that one. Well, the second one was it had to be large enough to be round. Well, asteroids aren't round, so we're not calling them planets. Rocky bodies like that sit around Mars, the 2 moons of Mars, Phobos and Deimos, are both captured asteroids. So, and actually, as I mentioned, Ganymede, one of the moons of Jupiter, if it actually went around the Sun, it would be large enough to be a planet. But actually, they have to be large enough to be pulled themselves into a shape to be round. And Pluto does pass that one, so okay, great, there's 2 for Pluto. But the third one was where it gets stuck. So it has to dominate its orbital zone, clear out other sizable bodies as it goes around the Sun. The problem with Pluto is that every once in a while it drifts into Neptune's orbit, and there's no way that it could push Neptune out of the way. Basically, that's the basic theory behind it. So Pluto was denoted to a dwarf planet with other dwarf worlds called Ceres and Eris and many more now. Let's take a quick look at the size of things in the solar system. So, and we're going to compare those against some of the objects that we call stars. So here's a little video I found. It was kind of neat, I thought. So here's Earth's moon, Mercury, and Mars. And we can see that Mercury's just slightly larger than our moon. Here's Venus and Earth. We're about twin size here. Now we're going to zoom out to some of the gas giants in a view of Neptune. And of course, here's Saturn without rings. much larger with rings, over 100,000 kilometers across, Jupiter, and our Sun. Of course, our Sun is only one of many suns and not particularly large in its size. We have many others that are much, much larger, including Sirius, Pollux, Arcturus, the red giant star. We'll get into talks too maybe later about what these all mean. Here's a blue supergiant Rigel, which is the bottom right corner of Orion, and the Pistol Star. Antares A, Mu Cephei, and what was known as the largest star, there's actually one larger than this now, VY Canis Majoris. So now we're going to zoom in a small spacecraft, fly over the top of the star, zoom in close to it. We're going to take a look at the size of Earth compared to the star. And that's us. And not only have we found our solar system, but with the result of things like the Kepler spacecraft, we've actually found many other solar systems. I'm trying to get this back here now. Here's a small sampling of the solar systems that have been discovered by the Kepler spacecraft, which found over 4,000 planets, I guess, now to its record. And if you look at these, you'll see that the larger, redder objects are the larger planets, and the ones in the center are the smaller ones. You can see that they're a blue and yellow. Let's go back through that image again one more time. Here we go. Many other solar systems that have been discovered. Many of them have planets that are much larger than anything in our solar system. Some of them are called hot Jupiters. I can get into discussion about planets and how we find them and things on a later broadcast as well. See, there's lots of things here to talk about. I'm just trying to give you a quick image of what is out there. And when we looked with Kepler, this is the only piece of the sky through the Milky Way that we actually examined. So, I see my chat comments have been disabled somehow by YouTube, so I'll try to get them back again after a bit. But in this one here, I wanted to show you the size of nebula, and we talk about the Orion Nebula and other nebula that are quite common out in the galaxy.
Connected to EP2 JP209.
Trying to get this to work properly. There's our galaxy. There's a spirograph nebula. The Eskimo, the Hourglass, the Cat's Eye Nebula. Beautiful ring nebula, 2.6 light years across. A quick view of some nebulosity that's around our sky, in our night sky. I'm going to have to stop there because we're getting into 10 after 9 at the moment, so I didn't want to continue much farther past the point that I had suggested in the original view. And there was only a few other slides left. But what I wanted to do was maybe pop out and take a quick view at Stellarium and just show you quickly what's coming in our night sky over the next few days. So here's a view of our night sky on the 29th. We're going to take this back to today's date. And this is our view tonight looking southwest, with Jupiter and Venus being only about 1.5 degrees apart. And what's happening now is, of course, Jupiter is setting as Venus is rising. So Jupiter is going to be going in behind the Sun from our point of view, and Venus is just coming out from behind the Sun. So Venus is going to continue to be our evening star here for a little while, and I'm going to show you as we move ahead. So we're looking at our sky using a program called Stellarium. If you want to download it, you can go to a website called stellarium.org. Download the program freely to download. And once you set it up, there's just a few steps to set it up to find out your location. So here's the location window, and I can choose anywhere pretty well in the world as my location. And when I do that, it'll set it up. In my case here, it's St. John, New Brunswick. And there's lots of other options here that you can use to turn things on and off, like the constellations and the names of the constellations, and even some of the artwork is presented. So it's very user-friendly program. I use it often when I go out to set up for the public. It gives me an idea of what's happening in the night sky. So we have Jupiter and Venus here again in the southwest sky at 5:30 this evening. And let's advance it ahead a few days. And we can see what's happening here is that Jupiter's starting to set down in our southwest sky while Venus is rising. And on the 27th, I guess, maybe the 28th, on the 28th, there we are, we have, the moon is much larger than it would really be in this view. We have the moon, Venus, and Jupiter all forming a nice little triangle right here. And then the following day, the moon pops up towards Saturn, so it greets Saturn in our southwest sky. So that's what's happening in our evening sky. If we spin around to our morning sky, and we take our time down, let's go back over here to our southeast sky. Just a real quick view here, folks. And let's go back to our morning sky now. So we just change the time here. We'll take a look at our morning sky about 6:30 in the morning, and we'll wind ourselves back to the 24th again. So there's our waning crescent moon, just about to turn new, sitting beside Mars this morning, and Mercury just down below it. And if we watch this over the next few days as well, we'll see the moon is going to disappear from view because it's going to start appearing in our evening sky. So it comes up about an hour later each day. And now we have Mercury and Mars up in our morning sky. And this is going to remain our view for a little while now, as we can see that Mercury is going to start to drop, as it doesn't really get very far away from the Sun. So if you want to observe Mercury at all, this is the time to observe it if you can, over the next few days, as it stays just above the horizon there, maybe about 10 degrees above the horizon. So it is certainly visible with binoculars, but be careful, very careful, when you're out looking at Mercury, that you make sure that you're not glancing at the Sun as well. So the Sun comes up just after this as well, of course. So if you move it ahead even to 6:45, you can see the Sun still isn't up yet, just starting to break the horizon, but we still have some time there, right up till around 7 o'clock or so before the Sun breaks the horizon and we lose its view altogether. So keep an eye on that for the next number of days, like over the next week or so. Watch the dance of the planets. You'll get to see 2 planets in our morning sky spin around here at night, and we'll get to see 3 planets in our evening sky. And that's going to continue right through the week here. So that's about all I wanted to offer tonight. I wanted to say thank you very much for tuning in again. I know it's a bit of a different broadcast here tonight, more the fact that the weather just didn't cooperate, but we're hoping for clear skies next Sunday night, and we'll get back to offering live views again through the telescope, and we hope that we'll be able to, all of you will be able to join us back then again. So please leave any comments in the comment section there, and I'm happy to go back once I see the live stream start connecting again, I'm happy to go back and answer any comments that you might have. I wish everybody clear skies throughout the week here, and please tune in again next Sunday night when we hope to have some clear skies here in St. John. Take care, folks. Have a great week, everybody.